What we will discuss in this tutorial is about hinges and couple degrees of freedom. So recognize this little system again. I like to maximize that view bottom left so we see a little bit more. We go into the creation mode, and what you recognize in this situation now is that we have a rigid connection here on the left hand side, and you see it with this little square, which just restrain also the rotation on the right hand side. So if you load this element by a vertical line load like that one here, and we do the analysis, we receive exactly that what we expect. We see here the rich connection with the maintained right hand angle here, and what you see here is that we have here a constrained rotation with horizontal tangent. That is exactly the beam clamped at the left and the right hand side. What we would like to do next is that just would like to introduce on the left and right hand side ideal hinges with respect to uncoupled rotations in around all three spatial axes. So we go back to the creation mode, and I just open the element context menu, and you see here the Grundelement, the basic element number 1, which means rigid connections on both sides, left and right. So if we would go into Grundelement 2A or 2B, that would mean that we have either a hinge on left or on the right hand side, or if we go directly to Grundelement 3, basic element number 3, which means they will have now hinges, ideal hinges, as well on the left hand side and as well as on the right hand side. You see these hinges. And if we now repeat the analysis, we exactly receive what we expect. So we have a free rotation on the left hand side and the right hand side. And if we look into the distribution of the moment and also take the proper projection to the XZ plane here, then we receive exactly what we know about this kind of loading on a beam, that we have this QL squared over 8 bending moment quadratic distribution. That's exactly what we know from beam theory. Let's now modify our beam such that we have a hinge on the left hand side. That means at node A, the first node of these two, and a restrained rotation on the right hand side. How can we do that? So we go back into the creation mode, open our context menu, and let's choose Grundelement 2A, basic element 2A, which means at node A, the first node, we will now have the ideal hinge. You see it on the left hand side and nothing on the right hand side. And we do the analysis now, we nicely see here the restrained rotation on the right hand side, and here the possible rotation on the left hand side. Let's switch that off here. And straightforward, if we just choose Grundelement 2B, basic element 2B, what would that mean? It means we have a fixed side on the left hand side, no coupled rotations, and on the right hand side we have now the hinge. If we do the analysis, we receive exactly what we expect. The coupled rotation, the rigid connection to the column on the left hand side, and on the right hand side the possible rotations here with the hinge. So far so nice. I would like now to look at a different kind of loading. We take away this line load, take away the line load, and I would like now to load this beam here just in the center by a single load. How can we do that? That we can do just by introducing another node here, and you see for that we need this split option for the element. So we just introduced another node here just in the center of the span with this extra node, and here we now can apply another single load here in that direction. Here it is. And if we do the analysis, then we receive exactly that what we expect for this kind of structure, with instead of the line load now a single load here at the center. So what we would like to modify now the structure, that we would like to introduce now a hinge here below the load. And we have different options to do that. So one of the options would be just to change this right part, this extra new element, now into basic element number 3. That's one possibility. Here we are, and we do the analysis. So you see, its structure is now so weak that it's now exceeding here the screen because the scaling factor is too large. We can automatically adapt the scaling factor by double-clicking on animation. So the scaling is automatically adapted to a proper value, and we have now this typical responses here for the bending moments here, going into the proper projection exact. No. So for the complete structure here, no. MZ is not the right one. No. Here the exact projection, now it's okay. So we see what we expect, that here in this part of the structure there's no bending moment at all. Then we have this linear increasing bending moment here towards the connection, and it remains to be constant here in the column. If you like to want to know here the numbers here are the numbers. So that is one possibility, just to introduce this this hinge. I go back to Grundelement 2, what is it, 2b, so with the hinge on the right hand side, there we had been. So what are the other options? The other options, of course, that we just change that one here into 2b, so if we can do that, so 2b, then of course we again have here this hinge introduced, and we receive the same result. This is another option, but we have still a third option. I just go back here into Grundelement 1, basic element 1, where we had been here, where we just has been starting. So the next option, and that is one of the most flexible and powerful option, is to create here a so-called double node. A double click on the node. We come to here, and you see here this tab double, and that means we're introducing now another extra node exactly the same position, and here you have the possibilities that this new node is now either attached to element number 1, that is our initial element, or the new generated element after the split operation, that is this one to the right. So we attach it to the right hand side, and you save it, then you see this new double node, and still nothing happened. You see we have the double node called numbering number 6, and you see this node has just sharing the same degrees of freedom regarding to all the 6 displacement degrees of freedom, 3 displacements and 3 rotations as the alter node. If we save that and we do the analysis, still nothing changed here. Everything else as before. Wonderful. Perhaps we just switch that off here. Nothing had happened. But now we have the possibility to directly control the degrees of freedom which are coupled and which are decoupled. To introduce a moment moment hinge as we just had, that is the rotation around what you see here, the y-axis. That means if we decouple the rotation regarding the phi axis, then we have to work on the numbers degrees of freedom of the 2 nodes regarding the rotation phi y. So giving another number here other than 29, we would decouple the 2 elements with respect to this rotation and would introduce a specific hinge. If we know another degree of freedom which is not used yet, we can type it in, or if we don't know that, we can ask Stiff by typing in the question mark, saving that, and you see Stiff is just serving with the new number which has not been used yet, and we just receive, it seems to be the same displacement as before. The structure has become very soft. Double click on animate, and everything comes back to a reasonable display. So you see by double nodes which share exactly the coordinates as the alter node and respectively degrees of freedom, we can nicely couple and decouple respective degrees of freedom. If we minimize it, we can nicely show that in the 3D graph here. And I can just show you, then we can now really separate here the hinge actions here. Going back here, just again closing it, by giving the same numbers. But let's say, okay, let's open the rotation around the z-axis. So if we do that, then of course nothing had happened with respect to the bending, as we had before in the xz plane. But if we now would apply a little load in the y direction, a little load here in the y direction, load in the y direction, let's say 0.2, something like that. Not so much, because the structure becomes soft again. Then you see that we have in the z direction, in the y direction, exactly this hinge action with respect to this little load component in the y direction, while still here in the xz plane, in the xz plane, it's just scaling the load here, we still have this undisturbed bending action as we had before. Next, I would like to show you how to create other kind of hinges, in particular with respect to longitudinal degrees of freedom, and that also with respect to an inclined member, just like this diagonal for this little modified structure. We have this diagonal, we have this additional column, and you see here we have roller support. That means if we do the analysis, you see as here this node is moving to the right, and as a consequence we have here the diagonal tensile normal force. Here you see the value, and also if we just adjust the projection, you see here the distribution here of this bending moment. Perhaps I just scale it a little bit better. You see it, this bending moment along this diagonal. Okay, let's now try to introduce a hinge here in the middle of this diagonal. Because of that we need this option with respect to splitting elements. Remember the drop-down menu for the element, we split it just in the middle here into two elements. And as we would like to control the longitudinal deflection along this bar here, we just are modifying here the local coordinate system, which we just can do again by the context menu of the node. Double click on the node, we go to Geo, then we have here the DOF orientation, double click into there. So, and by that we can just take the orientation of element number 5, which was the unsplitted diagonal element number 5. After the splitting operation, the next element would be element number 6. So I just take over the orientation of element number 5 as the local orientation of the degrees of freedom at this node. Now you see the x direction is now along the diagonal. So if we do the analysis now with this modified degrees of freedom with respect to this inclined orientation, you see nothing has changed. Here for this diagonal we still have this longitudinal force, and if you compare the bending moment here at the top left, you will just see that we just still have the same value. So much about that. So now we have to introduce the hinge, and that was this idea with this double node. We go to here, double click, introduce a double node. The double node I just attach here to the element number 6, that is exactly here. So, and still you see all the degrees of freedom are the same. That means they have full coupling. And again, if we do the analysis now, nothing has changed. Still we have the respective normal force. And if you again compare the bending moment at the top left, of course, still the same thing. Okay, so let's now introduce our hinge, the longitudinal deflection. We would like to introduce a hinge, double click, and that would be the U displacement component, the longitudinal one, that one which is in a direction of the X coordinate here, the local X coordinate. So here we introduce our hinge. I choose unused degree of freedom. Yet unused is number 37. So we agree, and we do again the analysis. And what you see here, so we have now the hinge here. The two elements are decoupled in a longitudinal direction. As a consequence, the normal force is 0. Quite obviously, it's the numerical 0 to 10 to the minus 11. That is okay. So, but still you see, yeah, the bending moment is coupled along the diagonal. It's coupled, yeah, there's everything being transferred, and that's exactly what we expect of a hinge, only working for the longitudinal deflections. We could also control the shear forces. The shear force here for this element, also you see, it's just nicely coupled. The shear force is the constant, same value along the complete diagonal. Okay, yeah, that was a little introduction into how we can introduce hinges and in all kind of combinations with respect to inclined members, inclined elements, inclined degrees of freedom, with these options of the double node, and eventually with these basic elements with respect to the complete hinges for bending. Thank you very much. See you with the next tutorial.